Andreas, and thank you for the opportunity for speaking at this ENVRI committee meeting. I'm Gergely Sipos, working as the head of services, solutions, and support at the EGI Foundation, which is a long-standing partner of the ENVRI research infrastructures. And in this few minutes, I'm going to give you an overview of the EOSC-related project that EGI runs at the moment. This is the EGI flagship project because it brings together members of the pan-European infrastructure community and brings them together with a few scientific communities, including those that are in ENVRI. So I want to talk about what we do together and especially focus on the opportunities that this project makes for everybody in ENVRI to tap into the compute services that EGI-ACE offers and delivers, thanks to the co-funding of the European Commission and thanks to the co-funding of the different compute centers that are in the consortium. If you want to browse the slides offline, you can already access them through that link, which is at the top of the slides. In the talk, I will briefly talk about the service portfolio, which is the heart of this project. Then we'll talk about who we already serve through from the environmental science and climate research domains, which resonate with the topics in ENVRI. I will talk briefly about the impact that we see since the project started, which was a year ago. And I will talk at the end about the future of what's going to happen with the services and with the support after the current funding cycle is over. So let me start with the fact sheet of the EGI-ACE project, which is one of the EOSC-related projects, specifically focusing on a compute platform delivery. It started in January last year. It's 2.5 years long. It has 8 million euros coming from the Commission and 4 euros coming from the consortium members. And the mission of the project is to deliver the so-called EOSC compute platform that contributes not just to the services and the computing in EOSC, but also to the so-called European Data Commons vision, which aims to establish scientific data spaces that help European research area to exploit scientific data sets with the use of high throughput, high performance cloud technologies. The project itself is one of the families of projects that are running all in the same call. There are 5 of these projects. You can see their logos on this slide. EGI-ACE is focused on distributed computing. The DICE project, which is run by the EUDAT infrastructure colleagues, is focused on data preservation and storage. The OpenAir focused project is on open scholarly communication about different types of research objects and papers. And these 2 projects, the C-Scale and Reliance, are both focusing on Copernicus data exploitation in EOSC. So all together, these 5 projects collaborate via a shared agreement that was signed with the EOSC Future project, which includes many of you. And EOSC Future is running together with the different research infrastructures, not just from ENVRI, but from the broader ESFRI landscape. So let me move on to the service portfolio which the EGI-ACE project delivers. The project itself is fundamentally it's a service delivery project. So the payment from the Commission comes in a form of virtual access funding and is given to service providers based on the actual use of their services. And on this slide, you can see this layered or tiered architecture that we built up in the project, which has 3 layers in it. The first layer, the bottom layer, are the big irons, let's say, the hardware that integrates different types of cloud systems from academia, also from 2 commercial entities, T-Systems and Cloudflare, high throughput compute clusters, and high performance computing computers, supercomputers. These are made available through different kind of accessibility platforms that enable the federated, integrated use of these systems. And the use of these capacities for interactive computing, different types of cluster deployment on demand, artificial intelligence, machine learning, and large-scale workload management for massively parallel applications. In the project consortium, we also have more scientific or thematic service providers that are delivering more niche services tuned and designed for specific scientific areas. We call them data spaces because they integrate scientific data sets together with the computing capacity and enable online processing in the cloud. All of these are supplemented with service management processes and policies and tools that secure the proper operation, the high availability and reliability of the systems, and ensure resource allocation across the different providers. The services themselves are offered already through the EOS portal, and the users can interact with those services through the portal or through the open call that I will talk about shortly. So in each layer of this architecture, there are a higher number of services that are behind each of these functional blocks, enabling, for example, a single sign-on across all the service portfolio through the check-in system, which is compatible with the EOS AI solution, an application database and infrastructure manager to share applications across the different compute resources, data transfer service, and data caching mechanism to allow on-demand caching of data at the different sites. We have interactive computing with Jupyter Hub and Binder installation, which is a new service from EGI. We have automated deployment of cluster resources in a scalable way, distributed AI, machine learning systems, and workload management with the direct service. And overall, the processes and policies ensure that we can broker and allocate resources to different communities. We can measure the usage and accounting across sites and across communities. We can watch the availability and reliability of the sites and report of misuse or report errors to the providers. We can serve the users and operators with help desk, and we can continuously feed this back into the development pipeline in order to increase the services. The bottom layer incorporates the data centers and the compute centers. And now on this slide, I'm just focusing on the cloud data centers, which is a dynamically growing, both in terms of the providers and especially in terms of the users. At the moment, we have 27 cloud providers, and last year we managed to sign up the first one from outside of Europe, the Chinese Science and Technology Cloud, and later this spring, the South African astronomy site will offer and join this club with its cloud resource. The high-performance computing system, which I mentioned, is another new addition in the project, which will come online and will make available supercomputers in the same common platform, compute platform. These supercomputers and the way how they are integrated into the compute platform are piloted now through 4 providers from Bulgaria, Portugal, Turkey, and Spain, and is validated through 4 different use cases, 3 coming from the physics communities and 1 coming from the climate change community. And very soon, hopefully by the end of this month, we will have, in the next week, we will have the first milestone coming out of this work, which will be the first version of the so-called integration handbook of HPC providers, which will be validated by broader HPC centers later this year, resulting in a manual for HPC centers to contribute to the EOS Compute platform as resource providers, and also promoting this to providers and users outside of the core project. The services that are offered by the project, on one hand, are consumed by the so-called data spaces. The data spaces, we have 13 of those in the consortium. Each represent a combination of scientific tools and applications, scientific data sets, typically really large or really distributed data sets, and the compute capacity that the normal data centers and compute centers make available. And they combine these three into an integrated service which is offered online for online calculation to scientists. You can see here the disciplinary spread of these data spaces, and you probably see some overlap with the members of the ENVRI project as well. So just a quick overview of the environmental sciences and climate research data spaces that are most important for you. You can see here that these different data spaces use and rely on the different underlying platform and cloud and storage services from the consortium, and some of them already started operating from the beginning of the project. Some are coming online later this year, but all deliver their services as resource providers visible in the EOSC portal. And one data space, let me zoom into that one, is the ENES for climate research. And this slide I borrowed from the EGI conference last September, where Sylvie from CNRS presented this architectural overview, where the ENES community has accumulated big data over decades about the so-called Earth System Grid Federation, monitoring different kind of physical parameters like temperature and various other factors that describe the climate change. And these data sets are still sitting in those data provider and data archiver sites that is operated by the community. And inside the EGI-ACE platform, they built up a data cache that can cleverly pull in the data sets and the records in order to perform on-demand calculation triggered by the user request and the user demands, all secured through the EOS compliant AAI and monitoring tools, and using the data transfer mechanism offered from EGI-ACE. And this whole setup is advertised as an ENES data space service in the EOS portal and marketplace, so the users can access this high-level view via the different graphical interfaces that are designed for environmental and climate scientists. How the EGI-ACE services are offered for the users. So there are two main routes for getting in. One is the so-called business to user, or what we call business to user delivery. So any user can go to the EOS portal and marketplace and use the services. Some of the services are fully open access, so you don't need to even log in, just go and use them. Some, typically those that require big capacity underneath, are protected with a login and with the authorization extra step. And the other routine is through the EGI-ACE Open Call, which we designed for communities that typically want to combine multiple services and typically want to engage with the usage for several years. For them, we also offer consultancy, we offer customization features for the services, so it's a much more integrated and long-term partnership that we build up through the Open Call. The call itself is open continuously since we launched the project, and we evaluate the incoming request every 2 months. The next cutoff date will be on the 15th of February, so in roughly 2 weeks, and then 2 months after that. Oh, sorry, I clicked the link. And once we receive those requests, basically the big power of EGI-ACE is that we bring together providers from not only different background with different skills, but also that work with different funding models. I mentioned that the project is fundamentally a service delivery project, so we received a bulk of the funding from the Commission to use as virtual access funding, distribute the funding to providers. On the other hand, we use the existing fundings and new fundings that are coming directly from national agencies to the providers, and we matchmake those providers with the use cases that are national or institutional priorities for them. So we don't use the VA if we don't have to, if a provider is nationally or institutionally committed to support the community. And in this way, we can build up a much larger capacity pool that can serve the scientific communities. So those requests that come in to us, either through the EOSC marketplace or through the open call, are evaluated and matched with the most fit for purpose providers, where fit for purpose can mean both technical aspect and also business aspect or financial aspect. We collect the requirement from the user community, let's say the representative of a scientific research infrastructure, and we map those to the conditions and possibilities offered by the pool of providers in the consortium. And after the matchmaking results an agreement of what kind of providers can satisfy that given use case and community request, then we sign a so-called service level agreement and operation level agreements with the providers that fix the offering that we give as individual providers, the conditions of access, the availability, the response time, for example, in the helpdesk, and the different parameters that are important for the usage of the services. Through the open calls that I said we are running with evaluation every 2 months, we already received over 25 applications. And here is just a short snapshot of those that came in from the environmental sciences domains. You can see that they include underwater noise observation, marine data processing, SAPs, rather generic processing service that is used for different types of water management, forest mass, crops, grow evaluation. We have the plant phenotyping research infrastructure with the request and the Pangeo Earth System Science infrastructure. So this is a growing list. And I hope that as a result of this talk as well, some of you become interested in tap into this capacity and tap into these services, and we'll submit an application to the call so we can work together on the delivery. And besides the online services, we also provide consultants, we provide trainers, we provide so-called shepherds, which are kind of responsible person from EGI-ACE to make sure that a single use case or community is happy. We organize webinars with roughly monthly frequency, and we provide documentation quite extensively about the different services that are in the portfolio to help the developers within the scientific users actually integrate their solution with the platform themselves. We are pretty successful with the uptake, with the delivery. This graph just shows that since the beginning of the project, we have assigned more than 100 million CPU hours in total for the use cases that reached us. And here the distribution of funding is shown here. You can see that roughly almost a half of this funding that is covering this 105 million CPU hours is coming from the Commission in the form of the virtual access. Roughly 1/3 is coming from the national providers. So the sites that are delivering the capacity is actually making this available because they are institutionally or nationally committed. And roughly 1/4 of that is coming from the applicant itself. So sometimes the project approaches saying that we would like to use capacity, and we are able to pay for that because our grant includes the funding for that. And this graph shows, since the start of the EGI cloud service, the actual usage of capacity. You can see a steady increase with an acceleration since we started the EOSC Hub project. That was the previous big flagship, EOSC-related flagship of EGI. And since January last year, the EGI-ACE project further advanced this. So this is the actual use. It's not promises, it's not allocation for the future. This is the actual use that happened over the past years. And here we see a continuous increase and actually even an accelerated increase of usage. And that's what we expect to continue in the remaining 1.5 years of EGI-ACE. And let me close with this one.
Okay, thank you.
This is the last slide. Yeah, this is the last slide, just to show you what we expect to happen after the project is over. The compute platform that EGI-ACE delivers is becoming a fundamental layer for many of the services that are scientific services that are operated in EOSC and are exposed to scientific communities. Different VREs, different platforms, different frameworks, workflow systems are now relying on this capacity. So we would like the compute platform to become a kind of continued entity inside the so-called EOSC exchange. And to do that, we are influencing the future of the EC decision on how to finance this. We know that from next year, the project-based funding of the EOSC core and some of the exchange services will be turned into procurement action, and we are influencing that through EOSC Future in partnership with some of you on advising the EC on what kind of services to include under the procurement action. In order to be able to respond to the procurement, we need to have a strong portfolio that's used. And here is an opportunity also for some of you that those thematic services that you are offering with a broad interest to a large group of users, even across different environmental science disciplines, could be part of this action plan. We have, for example, the ENAS climate service or the SAP service that has been requested provisioning through the open call. But maybe there are other kind of broadly used, rather generic environmental science services that could be sitting on top of the EOSC compute platform and therefore be suitable for long-term delivery. So this is the link to remember that points to the EGI-ACE call, and through that one I encourage you to apply for access. Thank you.
Thank you.